Beneath a sky that never cleared, the earth once drowned in its own breath. Clouds swollen with heat rose into the heavens and collapsed again, spilling oceans from the air. Day after day, season after season, century after century, the rain did not stop. It fell in torrents that swallowed rivers, then valleys, then entire continents, until the outline of the world blurred and the familiar balance between land and water collapsed in every age. Humanity has feared the depths, the cold darkness of the sea, the threat of drowning, the silence beneath the waves. But in this forgotten chapter of prehistory, the fear was reversed. To walk upon the land was to risk suffocation, starvation, and extinction. The rain turned forests into marshes, deserts into lakes, and mountains into isolated islands cut off by endless floods. The land itself became uninhabitable, a place where creatures perished under a sky that wept without mercy. And so, for millions of years, the water offered the only fragile refuge. Imagine an earth where no horizon was dry, where every sunrise revealed a sky already heavy with storms. Lightning etched scars across black clouds, waves thundered against continents, and the air itself was thick with the breath of steam. Planet trapped in mourning, where the boundary between sky and ocean dissolved into a single endless flood. What kind of world was this, when water was safer than land? What force could drive the skies to such relentless sorrow, to rains that reshaped the course of life itself? In this drowned earth lies a mystery, a storm so vast, so eternal, it rewrote the destiny of the planet, and within its memory lingers the haunting image of a world adrift, a time when survival meant surrendering to the flood. In the silence of stone, the earth remembers, buried deep in mountains and locked within cliffs. The planet has preserved its own testimony, records not written in words, but in layers of rock and grains of dust. When geologists first split open those layers, they did not expect to find the echo of a storm that lasted longer than civilizations, longer even than species. Yet there it was, a signature etched into time itself. Chemical traces revealed sediments stained with unusual isotopes, the unmistakable fingerprints of endless rainfall. Within these rocks, the story of drowned landscapes was sealed, fine. Particles washed from eroded continents, compressed and fossilized in rhythm with skies that never cleared. Like the pages of a vast diary, each layer told of rivers swollen beyond their banks, of valleys lost beneath floods that returned not for days or seasons, but for millions of years. The fossil record carried its own silences. In eras where lush forests should have spread across land, a void remained. Species vanished without clear cause, leaving behind broken patterns in evolution, as if the pulse of life had been interrupted. Creatures of water, however, endured and diversified, filling seas that had become the planet's sanctuary. The imbalance spoke of a truth too large to ignore. The land itself had become hostile, uninhabitable beneath the relentless weight. From the depths of the Pacific and Mediterranean, cores were drawn upward, cylinders of sediments stretching like scrolls across the ages. They revealed uninterrupted sequences of material, swept from continents into the sea, proof of rainfall so constant that it reshaped the chemistry of entire oceans. Salinity shifted, plankton communities transformed, and the pulse of Earth's climate faltered under the pressure of water unceasingly delivered from the sky. The story, however, was not found only in stone and sea. Across cultures, echoes of a memory older than writing persisted, myths of endless floods, of skies that poured forth oceans, of land consumed by water. While these tales were woven into the fabric of human imagination, They carried a resonance, as if the memory of ancient storms had been dimly inherited, passed not through records but through the deep corridors of collective fear. Linking these disparate voices, rocks, fossils, sediments, and myths, was a culprit hidden beneath the earth itself. Vast volcanic provinces, now cold and silent, had once erupted with fury. From there fissures poured floods of basalt and, more insidiously, invisible gases. Carbon dioxide and methane filled the air, trapping heat, driving oceans to evaporate, and priming the skies for an era of unbroken storms. These outbursts rewrote the chemistry of the atmosphere, creating the conditions for a planet-sized monsoon that would not relent. What began as whispers grew into suspicion. Perhaps Earth, in its deep past, had entered a state unlike anything humans could imagine, a super-monsoon epoch, where the boundary between sea and sky collapsed, where the rhythm of rain defined life and extinction. The evidence was fragmentary, scattered, incomplete, yet with every core drilled, every fossil uncovered, and every volcanic plain surveyed, the suspicion grew heavier, more undeniable. The drowned world was not myth but memory, a chapter in Earth's long history waiting to be understood. The puzzle deepened as scientists began to connect time with cause. The strange layers of rock that bore the marks of endless rainfall were not random. They coincided with one of the most violent volcanic episodes in Earth's history, the Rangelia eruptions. Across what is now Western Canada, a colossal outpouring of lava once spread across a region the size of Europe. It was not the lava alone that rewrote Earth's climate, but the gases it released in unimaginable volumes. Carbon dioxide surged into the atmosphere, and with it came the slow but inexorable thickening of Earth's greenhouse blanket. The oceans grew warmer, the air grew heavier with water vapor, and the climate tipped into a state where balance was no longer possible. Once the cycle began, it could not easily be undone. What followed was not a storm in the human sense, no passing weather pattern, no season of unusual rain. This was an atmospheric transformation that lasted millions of years. Scientists piecing together the evidence realized they were not studying a disaster confined to a single valley or a single continent, but a planetary-scale reconfiguration of climate. Rivers that once carved gentle paths through landscapes became swollen torrents, carrying entire mountain slopes to the sea. Soils stripped by unending downpour washed into oceans, filling basins with silt that buried ecosystems and altered the chemistry of the waters. The planet was locked in a feedback loop, where every drop of rain carved further instability, and every moment of instability summoned more rain. The fossil evidence told of life caught in the balance. Land plants, unable to withstand soils waterlogged for centuries, collapsed in great die-offs. Forests that might have stretched across the supercontinent of Pangaea disappeared, leaving behind traces of spores and pollen frozen in the geological record like fragments of a drowned library. Animal life fared no better. Amphibians, reptiles, and early lineages of creatures attempting to colonize land dwindled or vanished, their remains scattered in mudstone as silent witnesses to skies that would not relent. And yet, in the oceans, diversity expanded. Marine reptiles, mollusks, and plankton found niches to fill as new ecological spaces opened in the wake of land's devastation. The water was not safe, but it was survivable, a paradox that marked this era with both destruction and renewal. What haunted scientists most was the scale of time. In human imagination, floods are events measured in weeks, months at most, years. But here, the evidence spoke of 2 million years of rain. generations of storms rising and falling with no reprieve, a span so vast that entire species were born, lived, and went extinct beneath skies that never cleared. To contemplate such a world is to confront the scale of planetary processes beyond human comprehension. A climate machine, so immense that it could remain locked in storm for longer than the entire existence of humankind. The notion of a super-monsoon epoch emerged not as speculation but as necessity, the only way to reconcile the chemical scars in the rocks, the emptiness in the fossil record, and the rhythms of sediment on the ocean floor was to accept that Earth had entered a state unknown to modern experience. This was not weather, nor climate as humanity understands it. It was a transformation in which the atmosphere itself became an ocean, pouring its weight ceaselessly onto the land. Each new discovery added depth to the story. The dark clays of the Dolomites in northern Italy revealed ancient deluges that drowned Triassic ecosystems. In China, strata of the same age told of torrential floods reshaping entire basins. From South America to Europe, evidence converged. Across half a world, painting a picture of a global event that spared no region, the Earth itself seemed to whisper the same refrain across continents. There was a time when land could not be trusted, when survival belonged to the waters, and so, from the fragmented voices of stone, shell, and myth, a single truth began to take form. The drowned Earth was no allegory, no fleeting storm exaggerated by imagination. It was real, carved into the bones of the planet. Its memory lies beneath our feet, waiting in every rock and fossil, reminding us that the calm landscapes of today rest on a foundation of storms beyond measure. The origins of this discovery were not in the imagination of storytellers, but in the patience of science uncovering the memory of a world long ago, when water was safer than land. When the first pieces of evidence emerged, they seemed almost impossible to accept. To imagine rain falling not for years or centuries, but for millions of years, stretched beyond the limits of reason. Many scientists resisted, for the idea sounded more like legend than geology, more like myth than science. How could a planet sustain such imbalance? How could skies remain unbroken for such an incomprehensible span of time? Models of climate, as they were then understood, insisted on balance. Storms gave way to calm, floods gave way to drought, and cycles restored themselves. A world where the equilibrium broke entirely seemed a violation of natural law. The earliest responses reflected this disbelief. Some dismissed the chemical signatures in rocks as anomalies, local distortions rather than global truths. Others suggested that gaps in fossil records were artifacts of preservation, mere coincidences of geology rather than signs of collapse. Yet the silence within those records was difficult to ignore. Entire forests that should have spread across Pangaea's vast interior appeared absent. In periods when land creatures should have flourished, the record lay hollow, as if whole worlds had been erased by water. The absence was too profound, too consistent, to be easily explained away. Debate grew sharper as evidence accumulated. Were the strange sediments and drowned soils remnants of vast volcanic eruptions? The so-called flood basalts that could drench the air with carbon dioxide and poison the skies with sulfur? Or did the signs point to something greater, a climate, state beyond eruption, beyond even catastrophe, where feedback loops carried Earth into a storm of its own making? The arguments echoed across conferences and journals, as geologists, climatologists, and paleontologists struggled to reconcile what they saw in stone with what they believed possible in nature. Alternative theories were raised, each carrying its own allure. Some pointed to the possibility of an asteroid impact, for such collisions have reshaped the planet before, draping skies with dust and altering climates overnight. Others suggested orbital cycles, the slow celestial rhythms described by Milankovitch, tilts and wobbles of Earth's axis that shift monsoons and bring ice ages. Perhaps, they argued, the rains were not a single continuous storm, but a rhythm of wet and dry stretched and magnified by orbital mechanics. Still others returned to volcanic pulses, envisioning waves of eruptions driving intervals of greenhouse warmth and deluge, punctuated by brief respites before the skies opened once again. Behind the scientific dispute, a deeper question lingered. If the planet could truly sustain such unrelenting rain, then stability itself was an illusion. The image of Earth as a self-regulating, gentle cradle of life stood in tension with the possibility of Earth as a chaotic system, vulnerable to runaway processes that could drown continents and silence ecosystems. The philosophical weight of this possibility hung heavily. If balance was fragile, then the story of life was not one of steady continuity, but of survival through chaos, of adaptation to tempests that could last longer than the rise and fall of species. The clash between skepticism and evidence was more than academic. It revealed a truth about science itself, that even in the face of data, the mind resists visions of a world so alien to human experience. Yet the rocks remained silent and unyielding, whispering their testimony of rains without end. As the evidence grew harder to dismiss, the debate shifted. What once seemed unthinkable began to demand explanation. The drowned world was not fading into myth. It was stepping into science, carrying with it the unsettling recognition that Earth's hidden chaos was far greater than once believed. Slowly, the resistance gave way to uneasy curiosity. The more the evidence was examined, the more it resisted dismissal. Rock cores taken from distant continents, separated by oceans and ages, all bore the same chemical fingerprints, sudden shifts in carbon, oxygen, and strontium isotopes, patterns that spoke of colossal environmental upheaval. The synchrony was undeniable. These were not local events, nor scattered anomalies. They were global, inscribed into the very skin of the Earth. What had first seemed like an exaggeration, a myth woven into stone, began to reveal itself as a planetary chapter written with geological precision. As the arguments shifted, so too did the methods. Scientists turned to computer models of ancient climates, feeding them with the known volcanic outbursts of the Triassic and the geography of Pangaea. What emerged from these simulations astonished even the skeptics. With greenhouse gases flooding the atmosphere, ocean evaporation soared. Warm, moisture-laden air gathered into colossal storm systems that spanned entire continents. Rainfall intensified, and with no mechanism strong enough to restore equilibrium, the skies refused to clear. Instead of passing storms, the models suggested persistence, an Earth trapped in a greenhouse loop, unable to escape its own feedback. It was no longer mere speculation that endless rain was possible. The mathematics of climate itself now suggested it was inevitable. Once certain thresholds had been crossed, the fossil record provided further weight. In the places where land life had once thrived, sudden disappearances marked the rock layers. Amphibians, whose fragile dependence on water made them vulnerable, suffered sharp declines. Reptiles, then rising to dominance, were forced into new ecological roles. Even the plants told the story. Spores of ferns surged in abundance, a classic sign of devastated forests struggling to regrow after catastrophe. These clues aligned with the vision of skies that drowned landscapes, of ecosystems collapsing. Under the weight of ceaseless deluge, each fragment of evidence reinforced the idea that the rain was not a local disaster, but a global transformation. Still, the mystery remained unsettling, for it implied that Earth's climate could tip into states utterly foreign to human understanding. A world where rain never ceased was more than an academic curiosity. It was a challenge to the very notion of planetary stability. If such chaos had once occurred, then it could occur again. This possibility cast a shadow over the debates, turning scientific inquiry into a meditation on fragility. Earth was not a passive stage upon which life played its story, but an active, restless force capable of reshaping the script entirely. Among the community, a philosophical unease took root. Scientists are trained to measure, to quantify, to ground discovery in data. Yet what they faced in this drowned epoch was also a confrontation with imagination, the task of envisioning a world that had no modern parallel, no living witness. It was a reminder that science often begins at the edge of disbelief, where reality proves stranger, harsher, and more extraordinary than myth. The storm that lasted millions of years forced a shift in perception that the Earth is not merely stable, but precariously balanced. Its history a rhythm of long calms, punctuated by cataclysms beyond comprehension, as debate gave way to reluctant consensus. The first scientific reactions marked the threshold of a new understanding. The idea of a super-monsoon epoch no longer belonged to speculation nor to legend. It stood at the heart of geology and climatology, demanding to be studied, explained, and accepted. And though the scientific community had resisted, it was now clear the drowned world was real. Its memory had survived in stone, and its lessons would reshape humanity's vision of the planet it calls home. The first clear picture of the drowned world began to emerge, not in the laboratory, but in the high cliffs of the Italian Dolomites. Here, in jagged peaks carved from ancient seabeds, geologists found layers that darkened suddenly, shifting from pale limestone into black, organic-rich clays. These dark bands stood out like scars across the mountain walls, telling of a moment when sunlight faltered, seas grew restless, and the land sent torrents of soil and debris crashing into the waters. Within these bands lay the first unmistakable proof of the Carnian Pluvial episode, a chapter written some 230 million years ago, when the Earth itself became a storm without end. Close examination of these strata revealed more than color. Locked inside were spores and pollen grains, microscopic relics of vanished forests. Their abundance and diversity shifted abruptly, with entire plant lineages collapsing as if drowned beneath skies that would not relent. Fern spores, long associated with ecological recovery after catastrophe, surged in dominance, a living signal of devastation and rebirth. The story these grains told was unmistakable. Vast stretches of Pangaea's forests had collapsed, their soils stripped, their ecosystems erased, leaving only fragments of resilience to mark their passing. The oceans, too, bore witness. Chemical analysis of marine sediments revealed sudden and dramatic changes. Fresh water poured in from swollen rivers, diluting salinity and disrupting delicate balances that had persisted for millions of years. Plankton communities shifted in response, some vanishing entirely, others rising to fill the void. It was as if the oceans themselves had been forced into a new identity, reshaped not by slow evolution, but by the sudden weight of a planet's unbroken flood to uncover these Stories demanded endurance and sacrifice. Scientists ventured into remote valleys and perilous mountain passes, chiseling samples from stone that had endured for ages. In the Dolomites, teams worked along sheer cliffs where seas once lapped against warm Triassic shores. In China, they traced the same signatures across distant basins, confirming that the strange darkening was no regional anomaly but part of a global rhythm. Each discovery carried both revelation and weight, for with every core and sample the picture grew clearer. This was not a single storm, nor a fleeting catastrophe, but a planetary transformation. The dawning realization was profound. For centuries, floods had been the language of myth, stories of punishment, renewal, or survival carried by human cultures across the globe. But here was evidence of a flood that transcended myth, an epoch where the flood was not days or weeks, but millions of years written into the planet's skin. What had once seemed a poetic exaggeration now stood as geological fact. The earth had drowned itself in rain, reshaping the trajectory of life in the process. The early investigations into the Carnian Pluvial episode revealed the fragility of stability. A balance that had seemed eternal was undone with startling speed. Landscapes collapsed, oceans transformed, and ecosystems reconfigured under skies that refused to relent. The scientists who pieced together these fragments were not merely uncovering the story of an ancient storm, they were discovering a truth about Earth itself, that beneath its calm surface lies a restless capacity for upheaval, and that even the most enduring landscapes can be erased when the sky decides not to stop weeping. The Dolomites became the first canvas upon which the drowned world revealed itself, but as geologists ventured further, they found the same strange script written into the earth on every continent they touched. In the tropical basins of southern China, outcrops told the same story. Bright marine limestones fading abruptly into darker, mud-rich layers heavy with organic material. The change was not gradual, not the slow breathing of an ordinary climate cycle, but a sudden and decisive shift. Within the space of a few meters of rock, the memory of only a handful of millennia, the earth had lurched into a new state. The skies, it seemed, had chosen not to rest. Fieldwork in these regions carried its own challenges. Teams often hiked for days into remote valleys, burdened with drills, chisels, and packs heavy with samples. The work was painstaking and physical, yet its reward was revelation. Each thin slice of stone, once polished and studied under the microscope, offered windows into vanished ecosystems. Scientists found spores preserved like glass beads, pollen grains trapped in the mineral grip of time. Their abundance waxed and waned with sudden violence, as though entire forests had collapsed, leaving only fragments behind. Ferns thrived in the aftermath, a botanical chorus of survival, their spores marking the scars of devastation as faithfully as tombstones in a cemetery in the ocean cores. The story grew more complex. Sediment drilled from the depths revealed rhythmic pulses of clay and silt, carried by rivers that had swollen beyond measure. These layers whispered of rain that carved mountains into dust, of rivers that tore valleys apart and carried their burden to the sea. Chemical tests showed the unmistakable signs of fresh water flooding marine environments, shifting the balance of salinity in ways that reshaped entire ecosystems. Plankton, the foundation of marine food webs, rose and fell. In response, some lines extinguished while others seized the chance to flourish. The oceans had not merely absorbed the flood, they had been rewritten by it. The further scientists searched, the more the pattern repeated. In South America, in North America, In Europe, wherever they dug, the same abrupt transitions marked the record. This was no local catastrophe, no isolated disaster confined to a single region. It was global, a planet-wide upheaval, its fingerprints pressed into every continent and every ocean. What had once seemed a strange curiosity in Italian cliffs now grew into the outline of an epoch, a moment in deep time when the entire world became a storm. Yet even as the evidence mounted, the question deepened. What force could drive the skies to weep for so long? The rock layers told of consequences, drowned landscapes, collapsing forests, shifting oceans, but they only hinted at the cause. The answer, many suspected, lay in fire rather than water. Across what is now Western Canada stretched the remains of one of Earth's great volcanic provinces, Rangelia. Around the same time as the darkened clays of the Dolomites were laid down, Rangelia had unleashed floods of basalt across thousands of square kilometers. With the lava had come carbon dioxide and methane in colossal volumes, altering the atmosphere and trapping heat. This heat drove oceans to evaporate more quickly, loading the skies with moisture, until the balance tipped into a new state, one where the rains did not stop. For the scientists of the early investigations, the realization was haunting. The Earth had not been nudged by an external blow, not struck by a comet or asteroid in this case, but had undone itself from within. Volcanic fire had summoned endless water, and in that paradox lay the seed of transformation. The drowned world was not a story of punishment, nor of accident, but of a planet's own rhythms, its restless capacity to swing from calm to chaos. The more they uncovered, the clearer it became. The Carnian Pluvial episode was not a footnote. In prehistory, it was a turning point. The endless rains had stripped ecosystems bare, but in doing so, they had opened paths for new life to emerge. Forests regrew in strange new forms, reptiles diversified, and among the survivors were early dinosaurs, small and fragile at first, but destined to rise in the wake of the flood. The storm had destroyed, but it had also cleared the stage. Out of a drowned world, a new era was born. The breakthrough came not in the open field, among cliffs or windswept valleys, but in the quiet interiors of laboratories where stone was coaxed to reveal the secrets of vanished skies. Thin slices of rock, barely thicker than paper, became windows into a past world, each layer shimmering with chemical ghosts. Within them, scientists traced isotopes of carbon and oxygen, the fingerprints of an atmosphere thrown into chaos, ratios tilted away from equilibrium, pointing not to the hand of chance, but to the breath of fire. The culprit was found half a world away, written in black basalt, stretching across the bones of Western Canada. Rangelia, a flood basalt province, born of unimaginable eruption, had poured lava over an area the size of modern-day California. But the stone itself was not the deadliest consequence. With every fissure that split, and every fountain of molten rock that rose, greenhouse gases surged into the sky. Carbon dioxide, methane, and sulfur compounds ascended in volumes that dwarfed any eruption in human memory. What followed was not a mere warming, but the slow ignition of a planetary feedback loop. As the world warmed, oceans stirred under the fever. Vast surfaces of water surrendered their vapor to the air, loading the sky with moisture. Clouds thickened, heavy with potential, and once the balance tipped, It could not be undone. Rain fell, not in days or seasons, but in centuries upon centuries, cascading into rivers swollen beyond their banks, rushing into lowlands that drowned without reprieve. The atmosphere, primed by greenhouse heat, could not release its burden fast enough to return to calm. The cycle sustained itself, a storm, unbroken across millions of years. Chemical signals in marine sediments confirmed the link. Layers rich in organic material bore sudden shifts in carbon isotopes, timed precisely with Rangelia's volcanic pulses. In those same intervals, oxygen isotopes pointed to warming seas and rainfall far beyond ordinary monsoon cycles. The stone was not silent. It carried the echo of clouds that never emptied, of mountains ground down by rivers that never ceased to run. Advances in uranium-lead, dating closed the final gaps in the narrative. Minerals crystallized in volcanic flows were measured with atomic precision, their isotopic clocks frozen at the moment of eruption. These times aligned with the darkened clays of the Dolomites. The pollen bursts in China, the salinity shifts. In the ancient oceans, cause and consequence overlapped with uncanny accuracy. The basalt and the storm were one story, chapters written in fire and rain. What had once seemed improbable, rain that could last not for decades, but for millions of years, had now become undeniable. Earth had entered its longest storm, a climate locked into a state that erased coastlines, dismantled forests, and reshaped life itself. The evidence converged like rivers meeting at the sea. Chemical signatures, fossil silences, volcanic clocks, all pointing toward the same haunting truth. In the end, the realization carried both wonder and dread, for here was proof that the planet's surface, so seemingly steady beneath the rhythm of seasons, could be overturned by its own hidden engines. Fire could summon water, rock could command the sky, and life, fragile yet persistent, had been forced to endure under clouds that refused to part. The breakthrough did more than trace a line of cause and effect between fire and flood. It revealed the vulnerability of Earth's systems when forced beyond thresholds. Climate is not a passive balance, but a network of delicate interlocking gears, each capable of amplifying the other. When Rangelia erupted, it was not simply heat that entered the sky. It was the unlocking of feedback loops that spiraled outward, each reinforcing the storm's persistence. Warmer air could hold more water vapor, and water vapor itself is a greenhouse gas, thickening the atmospheric blanket. The more the planet warmed, the more vapor rose, the more rain fell, and the more heat was trapped, pushing the cycle ever further from stability. To understand the scale, scientists turned to models, digital reconstructions of the ancient world. In these simulations, volcanic gases were released into the Triassic atmosphere, oceans warmed, and clouds formed. The results were startling. The monsoon belt, normally a regional phenomenon tied to seasonal solar heating, expanded until it spanned nearly half the globe. Rainfall rates in certain zones multiplied several times over modern tropical storms, not for hours, not for days, but across entire geologic epochs. The models confirmed what the rocks whispered. This was no passing storm, but a climatic regime shift, a world drowned in its own humidity. Biological evidence mirrored the upheaval. Fossil pollen told of forests collapsing under the deluge, as waterlogged soils suffocated roots and new growth struggled against floods. Insects, which thrived in humid environments, experienced bursts of diversification, their remains scattered through sediments as silent testimony to the sudden shift. Yet for reptiles and amphibians on land, the record was harsher. Abrupt disappearances in fossil layers where continuity had been expected. Evolutionary lineages were severed, their disappearance marked not by violent catastrophe, but by the slow, unending attrition of rains. In the oceans, plankton populations shifted dramatically, their shells recording swings in salinity as rivers poured fresh water into basins that once had been stable. Even coral reefs, those ancient architects of marine life, showed scars of dissolution. Unable to anchor themselves in waters, turned turbid and freshened by incessant runoff. In this convergence of evidence, volcanic basalts, isotopic markers, fossil silences, and biological bursts, the outline of a global storm solidified. Earth itself had been transformed into a greenhouse basin. Clouds locked in place, the hydrological cycle stretched to its breaking point. The very atmosphere became a paradox. It rained so much that the skies remained heavy with water, unable to clear, unable to reset. This realization reframed how scientists thought about planetary habitability. Earth had not always been the stable cradle it seemed, its cycles of water and air gentle and predictable. It was instead revealed as a restless organism, capable of tipping into modes so alien they bordered on the unthinkable. The Carnian Pluvial episode, once dismissed as geological rumor, emerged as a planetary warning that under certain conditions, stability could unravel into chaos, and the very elements that sustain life could turn hostile. Yet what lingered most in the minds of those who pieced the story together was not only the science, but the haunting imagery it summoned. An earth wrapped in endless cloud, its skies darker than day, its mountains carved by rivers swollen with centuries of storms. A drowned world, reshaped not by an impact from above or a sudden freeze, but by the slow, steady persistence of rain, as though the planet itself had wept without end. The deeper the evidence was examined, the more the storm itself began to take on an almost mythic presence. It was no longer a question of whether the earth had endured endless rain, but of how such a thing could persist for nearly 2 million years. Storms, by their very nature, are meant to break. Clouds are meant to empty, skies are meant to clear. Yet here, in the heart of the Triassic, a paradox unfolded. The longer the planet raged, the more the conditions for its fury were renewed. The oceans were central to this puzzle. Water, vast and unyielding, holds the memory of heat better than air or stone. As volcanic gases trapped warmth in the atmosphere, the seas drank deeply of it, absorbing energy into their depths. But instead of quelling the fever, this absorption accelerated the cycle. Warmer oceans surrendered vapor more readily, filling the skies with moisture that returned again as ceaseless rain. The seas themselves became engines of the storm, releasing and reclaiming water in a rhythm that spiraled beyond balance. Earth had become a feedback machine, a world locked into a loop where every drop of rain fed the next. The storms themselves would have been unlike anything imaginable in the modern world. Supercharged by an atmosphere thick with vapor, lightning would have flashed with terrifying frequency, illuminating horizons where thunder never ceased. Winds, drawn from the violent exchange of heat and water, could have whipped into tempests of unimaginable scale hurricanes that dwarfed modern cyclones, sweeping across continents, erasing landscapes with the combined weight of rain and wind. In the perpetual twilight of storm clouds, day may have seemed no brighter than dusk, the sun glimpsed only as a pale disk through veils of vapor. The planet's surface existed in a state of dimness, shadows falling not from mountains or trees, but from the sky itself, life bore the consequences with stark finality. On land, animals accustomed to dry cycles and open forests struggled to survive. Habitats were drowned, migration routes cut off, and breeding grounds destroyed by endless flooding. Fossil records suggest that many species vanished quietly, not in an instant of catastrophe, but in the slow erasure of viable ground. Amphibians and reptiles that once dominated the margins of swamps and rivers faltered as their niches disappeared. Yet in the water, new opportunities unfurled. Aquatic and semi-aquatic life forms diversified, adapting to the surging rivers and expanded lakes. Insects, thriving in moisture, proliferated, shaping ecosystems that bent toward the wet. Life adapted. Not evenly, but through a brutal process of selection. Those bound to the land perished. Those bound to water multiplied. The rains themselves were double-edged. They washed nutrients from land into rivers and seas, fueling bursts of fertility. In aquatic ecosystems, algae bloomed in newly enriched waters, plankton multiplied, and marine food chains thrived. But this same fertility carried shadows of destruction. Runoff choked coastal waters, corals suffocated, and oxygen was stripped from stagnant seas. The rains were both giver and taker, sustainer and destroyer. A planet that wept so endlessly, nourished life and drowned it in equal measure. And then comes the haunting human perspective. To imagine such a world is to step into a landscape where the sky is never blue, where every morning begins with the sound of rain striking water, soil, and leaf. No fire could be kept dry for long, no structure safe from rot. Land would offer no refuge, only decay and danger. Survival would depend on surrendering to the waters, to floating, to drifting, to finding sustenance, not from the drowned earth, but from what the floods carried. The very definition of safety would be inverted. The solid ground beneath the feet, once a place of shelter, would be a place of peril. Only the water, unbroken and eternal, would offer a chance at endurance. The mystery deepened not simply in science, but in imagination. What forces conspired to hold the planet under its shroud for so long? Why did the gears of climate lock into such unrelenting rhythm? The rains were not random, not temporary, but sustained, as though the earth itself had chosen to embody sorrow, as though the heavens had forgotten how to stop weeping. The storm was no longer just a geological event. It was a revelation of how delicate and how volatile the balance of life's stage can be. The deeper scientists looked, the more the mystery seemed to expand into realms beyond simple explanation. The earth was not merely wet, it was transformed into something almost alien. In the silence of laboratories and the solitude of remote field sites, researchers found themselves confronted with the paradox of persistence. Why did this rain not simply collapse back into balance? Every known climate cycle had its rhythms, ice advancing and retreating, monsoons rising and falling, oceans breathing in warmth and exhaling it again. But here was something else entirely, a state of endurance, where chaos became the new equilibrium. One possible key lay in the hidden machinery of volcanism. Rangelia did not erupt once, but impulses episodes of fire spaced across hundreds of thousands of years. Each time the skies might have begun to settle, another surge of carbon dioxide and methane was thrust into the air. The atmosphere never had a chance to recover. It was not one storm, but a succession of storms, stitched together into a continuous epoch by the breath of the Earth's own mantle. The basalt provinces, now silent and cold, still bear the scars of these eruptions. Each lava bed a frozen heartbeat of the storm it helped sustain. To the imagination, such a world becomes almost unbearable to picture. The very concept of weather dissolves. There are no seasons, no reprieves, no moments of calm between tempests. Instead, climate itself becomes weather, an unending deluge. Storms without horizon, thunder rolling not as punctuation but as atmosphere. The forests that had once stretched across Pangaea were reshaped into swamps and mire, their trunks rotting in standing water, their canopies torn by winds that never ceased. The soil beneath became soft, unstable, carrying the stench of decay. Unable to anchor life, from above, this earth might have resembled a water world. Its cloud systems stretched like endless gyres, colossal hurricanes feeding off one another in belts that encircled the equator. Lightning storms would have been visible from orbit as flickering scars on the night side, so continuous they blurred into luminescence. In this vision, the planet itself looked less like a terrestrial home and more like an experiment in atmospheric excess, a cousin of Venus, not yet consumed by fire but drowned in its own sky. The comparison to other worlds became irresistible. On Venus, a runaway greenhouse effect locked the planet in a furnace, its surface hotter than molten lead, its skies forever shrouded in sulphurous clouds. On Titan, Saturn's largest moon, methane rains fall in cycles across alien plains, filling lakes and rivers of liquid hydrocarbons. And here, in Earth's distant past, water itself became the agent of extremity, falling not in seasonal rhythm but in geologic permanence. Each of these worlds told a similar story, that climate is not a fixed gift, but a balance perpetually at risk, capable of swinging into modes far beyond what life is prepared to endure. And yet, within this deluge, life found strange footholds. Some species were extinguished, but others seized the chaos as opportunity. Amphibians adapted to swollen wetlands, early dinosaurs expanded in number, and in the oceans, marine reptiles and plankton diversified in waters newly enriched by runoff. This paradox, destruction and fertility intertwined, haunted the research. The rain was merciless, yet it also pried open doors for the next phase of evolution. The storm was not only an ending, but also a beginning, rewriting the script of life with the ink of water for humanity. Looking back across the abyss of time, the vision carries a profound unease. A world where the sky never clears is not only a geological event, but a psychological mirror. It invites a question that cuts deeper than data. How would the human spirit endure in such a place? Imagine children who never saw stars, cultures that knew no concept of dry, generations that lived and died under a roof of rain. Safety would no longer mean shelter on land, but adaptation to the ceaseless waters drifting between floods. Learning to build not against the storm but within it. The mystery of this epoch is therefore more than the persistence of weather. It is the persistence of transformation. Why did the earth hold its breath for so long in the form of rain, and why did it choose, eventually, to stop? The answer remains incomplete, lingering at the edge of modders and stone records. But one truth stands unshaken. The longest storm in history was not merely a climate, it was a world entirely. At the limits of understanding, science begins to sound like myth. The story of Earth's longest storm presses against the boundaries of what can be modeled, measured, or even imagined. To simulate a world in which the skies never cleared, scientists pushed their climate models into uncharted territory. Equations that described monsoons as seasonal pulses were stretched until the pulses broke, until the software began to conjure a planet locked in a permanent monsoon state. In these digital reconstructions, the land was never dry, the hydrological cycle was never at rest. The system did not breathe in and out as it does today, it only exhaled. The rain did not end because the atmosphere itself had no mechanism left to stop it. The key lay not only in the oceans below, but in the sky above. As temperatures rose, water vapor ascended higher, leaking into the stratosphere where it was never meant to linger. There, above the protective layers of circulation, it began to disrupt the global balance. Water vapor is the most potent of greenhouse gases, and in the stratosphere it magnified the heat, accelerating the cycle until the rain became self-sustaining. Earth, for a time, had drifted toward a threshold that mirrored the fate of Venus, where runaway feedbacks once transformed a temperate world into a furnace. Some scientists wondered whether the Triassic deluge had been a brush with that same abyss, whether Earth had teetered on the edge of irreversible collapse, only to step back before the fall. The stone record offered whispers of this tension. Paleomagnetic studies revealed that even as storms drowned the continents themselves were moving, drifting northward across the face of Pangaea. Mountains eroded into sediments that were carried into seas, recording both the violence of the rain and the slow churn of the Earth's mantle. It was as though to scales of time, storms lasting millions of years and tectonic shifts enduring tens of millions more were woven together, one reshaping the biosphere, the other reshaping the planet itself. And yet, even in this drowned world, life displayed a resilience that bordered on defiance. Microbial mats flourished in the swollen wetlands, weaving filaments across mudflats, stabilizing soils where larger plants had rotted away. Algal blooms spread in brackish waters, feeding the plankton that in turn nourished vast food chains. In the deepest sediments, where oxygen had vanished, anaerobic microbes thrived, transforming chemical gradients into energy, seeding ecosystems that would persist long after the rains ceased. The smallest organisms, too small to be noticed by the storm, became the architects of recovery. But still, the unanswered questions lingered. Why did the rains endure so long, and why did they end at last? What invisible threshold separated a temporary flood from permanent collapse? Did Earth skirt a catastrophe that might have erased habitability forever? Or was the deluge merely one chapter in a larger pattern of balance and renewal? The rocks, the models, the isotopes all provided fragments of answers, but never the whole. The mystery remained suspended between certainty and wonder, between the known precision of data and the vast unknowability of deep time. In contemplating this storm, science is forced to its own edge, where numbers become approximations and theories dissolve into speculation. It is here, at the frontier of knowledge, that the imagination must stand in for certainty. Earth's longest reign is remembered not only through the sediments it left behind, but through the haunting possibility that it could have gone further, that the planet might have slipped into a destiny from which there was no return. The comparison to Venus became a lens through which Earth's storm could be more deeply understood. Venus is a cautionary mirror, a world roughly Earth's size, forged of similar elements, yet transformed into a furnace where no ocean remains. Its dense atmosphere of carbon dioxide traps heat so fiercely that lead would melt on its surface. Above that hellscape float clouds of sulfuric acid, reflecting sunlight outward but trapping warmth within, creating a balance so warped it will never recover. Some scientists believe Venus once held oceans, shallow seas that evaporated under a warming sun, their vapor rising higher into the atmosphere. Once in the upper layers, ultraviolet light from the sun split the water into hydrogen and oxygen, and the hydrogen, the lightest of gases, escaped into space. What was left behind was irretrievable. The runaway greenhouse had claimed an entire planet. When researchers modeled the Triassic storms, they saw flickers of this same instability. With so much water vapor reaching the stratosphere, Earth too risked bleeding its hydrogen into the void. Had the volcanic fires burned longer, or had the sun's output been stronger, perhaps Earth would have joined Venus in silence, its oceans erased. Instead, the planet's orbit, its geological rhythms, and perhaps sheer fortune kept it balanced at the edge, drenched but not destroyed. The Carnian rains became not only a geological event, but a reminder of how fragile the line between habitability and catastrophe truly is. Yet even in this state of extremity, life persisted in ways both humbling and astonishing. Microorganisms, immune to the despair of scale, adapted as they always have. In stagnant floodwaters, where oxygen was depleted, anaerobic bacteria built layered mats, capturing carbon in chemical webs that stabilized new ecosystems. In the oceans, plankton adapted to fluctuating salinity, diversifying into forms resilient to both fresh influxes and marine depths. These tiny survivors seeded the renewal of life, ensuring that when the rains ended, ecosystems would have the raw material to begin again. Their endurance was not merely survival, but quiet defiance, proof that life itself is less fragile than the stage upon which it plays. The rains, however, were never a uniform blanket. Evidence suggests that some regions endured greater extremes than others. In the tropics, monsoons likely reached apocalyptic proportions, drowning forests and saturating soils until they collapsed into mud. Closer to the poles, conditions may have been more complex, with alternating deluges and brief dry spells that shaped mosaics of survival. Paleomagnetic reconstructions show that Pangaea's shifting position altered circulation patterns, influencing where the heaviest storms raged. In some places, rivers may have swollen to inland seas. In others, deserts may have briefly blossomed, only to be erased again by returning floods. The earth itself became patchwork, not uniformly drowned, but unevenly scarred. And through it all, the fundamental question remains: how close did Earth come to losing its balance entirely? Climate models can approximate, but they cannot capture every feedback, every unpredictable twist of chemistry and atmosphere. It is possible that the Triassic storm was a near miss, a planetary flirtation with irreversible collapse, or perhaps the system contained checks unknown to science, hidden stabilizers that eventually broke the cycle and returned the planet to equilibrium. The evidence cannot say. What endures is uncertainty, a silence in the record where certainty should be, a gap that humbles even the most advanced theories. This is what it means to stand at the extreme edge of science. Here, the questions outnumber the answers, and the limits of measurement become visible. Rocks carry signals, models simulate possibilities, but deep time guards its mysteries closely. The storm speaks only in fragments, enough to confirm its presence, but not enough to reveal its entire truth. And in this silence lies the most haunting thought of all, that even now, the Earth we know, seemingly stable and familiar, holds within it the potential to tip again. The search for understanding eventually brought scientists back to the most familiar of planetary culprits: volcanic fire. Across Earth's history, mass climate upheavals have so often followed in the wake of colossal eruptions. when the planet itself tore open and poured its hidden reservoirs of gas into the skies. In the Carnian Pluvial episode, the flood basalts remain the most compelling suspect. Spanning what is now western North America, this province of ancient lava once covered an area the size of modern-day Europe. Eruption after eruption released unfathomable volumes of carbon dioxide and methane, greenhouse gases that altered the balance of sunlight and atmosphere. Each pulse of lava may have been brief in geological terms, thousands of years at most. Yet in the context of climate, such pulses acted like hammer strikes on a fragile equilibrium. Heat built slowly but relentlessly, oceans warmed, and with them the atmosphere's capacity for water vapor expanded. Storm systems no longer dissipated, they multiplied, circling the globe with unbroken persistence. But volcanic fire alone was unlikely to account for rain that endured not just centuries or millennia, but millions of years. To explain this persistence, scientists turned to the heavens. Earth's orbit is never fixed. It wobbles, stretches, and tilts in slow, predictable rhythms known as Milankovitch cycles. These cycles alter the distribution of solar energy, sometimes amplifying seasonal contrasts, sometimes muting them. During the Triassic, orbital alignments may have conspired with volcanic warmth to create conditions ripe for relentless precipitation. The timing is striking. Layers of sediment rich in rainfall indicators appear in rhythm with orbital pacing, as though the planet's storms were tuned not only to earthly eruptions, but to celestial mechanics as well. Geography, too, played its part at the time. Nearly all of Earth's land was joined into the supercontinent Pangaea. This massive landmass reshaped the climate in ways unfamiliar to the modern world. With such vast continental interiors, seasonal monsoons would have been immense, sweeping across thousands of kilometers with no ocean to temper their force. As Pangaea slowly rifted and its plates drifted apart, the reshaping of continents further altered wind and ocean circulation, amplifying the instability. Where today's monsoons pulse in annual cycles, the Triassic may have experienced them not as rhythms, but as near-permanent states, locked in place by geography itself. Beneath the surface of the seas, another transformation was underway, as floods of fresh water poured from drenched continents into the oceans. Salinity dropped, and circulation patterns faltered. Deep currents, which today ferry heat and nutrients across entire basins, may have collapsed or stalled. Without these vast conveyor belts, heat accumulated unevenly, and regions that should have cooled remained warm, driving more evaporation and more rain. Chemical traces in marine sediments tell the story. Sudden disruptions in isotopic ratios suggest ocean mixing ground to a halt, a climate system stifled from within. The land bore scars of its own. Vegetation, stripped by endless storms, left soils exposed. Without roots to bind them, hillsides collapsed into rivers, feeding more sediment into swollen waters. This erosion darkened coastlines and choked estuaries, further altering the chemistry of seas. The loss of forests also removed a vital carbon sink, allowing greenhouse gases to linger longer in the skies. Thus, rain did not simply wash the world clean, it reinforced its own persistence. The storm became a feedback loop, destruction feeding climate, and climate feeding destruction, piece by piece. The evidence converges on a single picture, one of interwoven forces, no single cause alone sufficient, but together forming a planetary-scale catastrophe. Volcanic gases primed the atmosphere, orbital rhythms amplified their effects, geography shaped the storms, oceans lost their currents, and land itself surrendered its grip on stability. The Carnian Pluvial episode was not a disaster born of one anomaly, but the collision of many, each magnifying the other until Earth became trapped in its longest storm. Still, even as the evidence aligns, the narrative resists simplicity. For every layer of rock that testifies to volcanic gases, there is another that speaks of oceans rebelling in ways models still cannot capture. For every orbital cycle that seems to synchronize with rainfall patterns, there lingers uncertainty about whether such cycles could truly sustain storms for millions of years. The mystery of duration remains the most haunting question. How could Earth's atmosphere, so dynamic and restless, fail to find equilibrium for so long? In ordinary times, feedback loops close, excesses fade, and the climate restores itself. Yet here, the loops did not close. They expanded outward like cracks in glass, reinforcing one another until they became a self-sustaining chain of chaos. The analogy to today's climate lens, the enigma even sharper edges. Carbon dioxide spikes in the Triassic reached levels several times higher than modern concentrations, driving temperatures upward in ways no ice sheet could temper. With that much heat trapped, the oceans boiled more vigorously into vapor, saturating the skies until they could no longer remain clear. Models suggest that under such conditions, the hydrological cycle could behave less like a pulse and more like a torrent, an atmosphere unable to release water quickly enough, trapped in perpetual saturation. Even minor variations in continental geography or ocean salinity could have tipped this system further, ensuring that rain became not a season but an epoch. The living world bore witness in silence. Fossil evidence shows that terrestrial ecosystems faltered again and again. Entire families of plants and animals vanished from the record, their absence forming gaps where lush forests or teeming floodplains should have thrived. The rain carved their silence into stone. And yet the seas tell another story, one of expansion and opportunity. In marine sediments, the remains of plankton and ammonites appear in abundance, flourishing in nutrient-rich waters churned by runoff. Life, as it always does, adapted to catastrophe. Some niches collapsed, others bloomed. The Earth was not extinguished, but rewritten. For scientists, this paradox has become the key to understanding. The Carnian Pluvial episode was neither wholly a tragedy nor wholly a renewal. It was both. Rain became a sculptor, erasing entire landscapes while also sketching the outlines of new ecosystems. Volcanism, orbital shifts, geography, and ocean circulation collapse acted together not only to destroy but to create. In the wake of drowned continents, new evolutionary experiments began, setting the stage for the rise of dinosaurs, for the rebalancing of ecosystems, and, eventually, for the distant lineage that would give rise to humanity itself. What emerges, then, is not simply a tale of disaster, but a reminder of fragility. Earth's apparent stability, its seasons, its balances of land and sea, its rhythms of wet and dry, is a veneer, stretched over forces that shift with glacial patience and volcanic violence. The mainstream theories of the Carnian Pluvial episodes do not merely reconstruct a storm. They reveal the precariousness of climate itself. For 2 million years, the sky did not yield. And though equilibrium eventually returns, the memory lingers in stone, a warning that even the most familiar patterns can fracture when too many forces align. Some mysteries resist the neatness of consensus. Even when the bedrock of evidence points to volcanic fury and shifting countenance, There lingers an unease, the feeling that perhaps something more was at work, something unaccounted for in the balance sheets of geology. Here, on the frontier of speculation, science edges into territory where imagination and reason blur. For in the face of rains that lasted 2 million years, mainstream theories may explain much, but perhaps not all. One of the more daring proposals imagines a trigger from the heavens themselves. What if the skies were not stirred solely by molten rock, but also by stone from beyond? Asteroid impacts leave unmistakable scars, craters, shocked quartz, chemical signatures of iridium. While no crater has yet been tied directly to the Carnian floods, some researchers wonder whether smaller impacts, perhaps lost to erosion, may have acted not as singular cataclysms, but as atmospheric agitators. Each strike could have injected dust into the skies, dimming the sun briefly, cooling the surface, and then, paradoxically, fueling the hydrological cycle as volcanic gases and solar dimming played to guffaw. In this way, Earth might have been jolted into an unstable equilibrium, where rain never found reprieve. Another theory peers more closely at the breath of the volcanoes themselves. Not simply greenhouse gases, but the interplay of sulfur-rich aerosols and carbon dioxide, weaving cycles of cooling and warming that confuse the climate into chaos. A volcanic plume can blot out sunlight, seeding clouds, sending temperatures downward. Yet, as the sulfur settles and dissipates, the carbon dioxide lingers, pushing the thermometer back up. If these cycles overlapped for millennia, pulses of cooling rain followed by warming floods, the result might resemble the ceaseless weeping of the sky recorded in stone. Not a storm of constancy, but of perpetual oscillation, so violent that to those who lived through it, the distinction would vanish. Then there is the speculative language of orbital resonance. The gravitational pull of the giant planets is not static. Jupiter and Saturn, immense shepherds of the solar system, shape Earth's path in subtle, rhythmic ways. What if, during the Triassic, Earth drifted into a harmonic pattern, a resonance that stretched monsoons to planetary scale? Though models struggle to test such possibilities, the idea lingers like a half-remembered chord, a suggestion that the rains may have been written not only in fire and ocean, but in the celestial geometry of the solar system itself. Cosmic dust, too, has entered the conversation. Earth moves through swarms of interstellar debris, its atmosphere catching fine particles invisible to the naked eye. In ordinary times, this influx is negligible, a haze easily balanced by weather. But if the planet passed through an unusually dense stream of cosmic dust, it might have altered atmospheric chemistry in ways still poorly understood, providing new surfaces for water vapor to condense, accelerating cloud formation, and amplifying the rains. The evidence is faint and perhaps forever lost. Yet in a mystery this immense, even the quietest possibilities cannot be ignored. The most haunting speculation, however, is also the simplest. Some imagine that Earth nearly drowned itself. The self-drowning planet hypothesis suggests that once the rains began in earnest, feedback loops may have spiraled far beyond their origins. Warming oceans fueled storms, storms eroded soil, soil enriched the seas, seas released more carbon, and the circle closed upon itself. Left unchecked, such a system could, in theory, sustain itself indefinitely, an Earth trapped in a cycle of eternal rain. That it ended after 2 million years might have been luck, coincidence, or the slow exhaustion of volcanic breath. But it raises a sobering question. How close did the planet come to never stopping at all? And as the mind drifts to this precipice, Speculation shades into philosophy. Could such storms come again? The forces that shaped them still exist. Volcanoes, orbital shifts, cosmic debris, the delicate balance of oceans and air. In the face of human-driven climate change, whispers of the past gain new resonance. The drowned Earth of the Carnian Pluvial episode stands not only as history, but as warning. A reminder that balance is fragile, and that skies can break in ways far beyond imagination. If once water was safer than land, could the future one day echo that fate? The speculative edges of this mystery invite a kind of awe tinged with unease. For when mainstream explanations falter, humanity's imagination widens the canvas, daring to see Earth not only as a system of rock and air, but as a stage for cosmic experiments whose rules are still only dimly understood. Each fringe idea acts as a mirror, reflecting both the vastness of nature and the limits of comprehension. Asteroid impacts, volcanic aerosols, planetary resonance, interstellar dust, they may sound improbable, but so too would the notion of a 2 million year rainstorm had the evidence not been carved into stone. The strangeness of the past demands openness to the strangeness of possibility. Some researchers take the thought further, tracing the parallels to Venus. There water once existed. Oceans may have stretched across its surface, and yet the planet crossed a threshold it could not retreat from, a runaway greenhouse state, where oceans boiled into vapor and the sky thickened into a suffocating shroud. Could Earth have stood on a similar precipice during the Carnian storms? If the rains had been sustained just a little longer, if the volcanic exhalations had lasted a few million years more, perhaps the feedback loops might never have ended. The Earth, known today, with its temperate seas, green countenance, and fragile balance, might never have emerged. The thought unsettles, reminding that stability is not destiny, but fortune. And then there are the myths, those echoes of human memory. Nearly every ancient culture holds stories of great floods, of skies opening without pause, of land vanishing beneath waves. Mainstream science regards these as allegories, cultural expressions of fear and survival. But what if some memory lingers, however distorted, of times when the Earth itself wept endlessly? Speculation here is less about geology than about the shared subconscious of a species trying to make sense of forces beyond comprehension. Whether rooted in fact or dream, these myths serve as reminders. Humanity has always known that the sky is capable of betrayal. The speculative theories converge on one philosophical thread: fragility. A planet that can tip into 2 million years of rain is not a planet immune to chaos. It is a planet balanced precariously between equilibrium and upheaval. And though the storms of the Triassic eventually ended, they demonstrate that catastrophe need not come from sudden impacts or singular explosions. It can arrive slowly, insidiously, through feedbacks invisible at first, but unstoppable once unleashed. To contemplate the speculative is to confront the unknown boundaries of the possible. Asteroids may have missed their mark, dust streams may have passed, resonance may have shifted, but the lesson endures. Earth exists within a web of forces, volcanic, celestial, atmospheric, cosmic, any of which can, under rare alignment, drag the planet into states that seem impossible until they arrive. The drowned world of the Carnian Pluvial episode is proof that impossibility is often only a matter of time. In laboratories and field camps across the world, the drowned Earth of the Carnian is no longer just an ancient riddle. It is an active investigation, its fragments drawn from stone and sea to be reassembled into a portrait of catastrophe. Scientists today push drills deep into the crust of the Mediterranean, the Pacific, the South China Sea, extracting cores that carry within them the layered breath of storms long gone. Each thin band of clay and silt is a page in a book written in rainfall, where chemistry becomes language, and every trace of carbon or oxygen isotope, whispers of skies that once refused to clear. Supercomputers now extend what the stone cannot show. Climate models, intricate and immense, simulate the physics of heat, air, and ocean during the Triassic. They recreate clouds, building upon clouds, monsoon belts swelling until they span continents. The hydrological cycle pushed into overdrive. What was once unthinkable rain, unbroken across millions of years, emerges not as fantasy, but as a rare and terrible state into which the Earth can indeed be forced. The models reveal how volcanic gases trapped heat, how warm seas evaporated endlessly, how feedback loops locked the planet into a rhythm of storm. It is a science that does more than describe. It resurrects a lost world, giving shape and breath to the silence of fossils and stone. The fossils themselves, too, continue to rewrite the story. In the mudstones of Europe and China, bones of early dinosaurs appear precisely after the rains receded, as if the storm itself cleared the stage for their rise. Where amphibians once dominated, their fragile skins unable to withstand altered climates, reptiles with tougher hides and lungs began to flourish. The drowned world, though destructive, became a crucible of opportunity. It was in the aftermath of endless storms that one of Earth's most iconic dynasties began its reign, destined to last for over 150 million years. And so, the past becomes inseparable from the present. For, in the Earth's modern climate, scientists see echoes of the same dynamics. The principle that the wet grows wetter. Regions already prone to rain may see deluges deepen, while drought sharpens elsewhere, just as it did in the ancient Triassic. Volcanoes today do not flood the skies with carbon dioxide, as Rangelia once did, but humanity itself has taken up the role, raising greenhouse gases to levels not seen in millions of years. The question grows heavier with every year of rising. Heat, are the patterns of the Carnian Pluvial episode a prophecy of what is to come? A faint but growing resonance between ancient storms and modern change. These investigations are not the work of single minds or single nations. Geologists sift through sediments, paleontologists unearth the bones of creatures who endured the storms. Climatologists weave simulations from mathematics and physics, and chemists decode isotopes into records of lost temperatures. The mystery of the drowned Earth has become a global collaboration, a chorus of disciplines converging on the same question. How close does the modern world stand to repeating its ancient trials? The efforts continue, each new drill core, each fossil bed, each line of code adding another thread to the tapestry, yet the central enigma persists. The storms of the Carnian ended, but why? And if they ended once, could they begin again? The search is not only for answers to the past, but for warnings to the future, for in the silence of stone lies the memory of a planet that nearly drowned itself, and the Earth of today, restless and warming, listens faintly to that memory, as if the ancient rains were still falling somewhere just beyond the horizon of time. Satellites now sweep across the planet with eyes sharper than any that have gazed upon Earth before. From their vantage in orbit, they measure the thickness of clouds, the temperature of seas, the slow shifting of rainfall patterns across continents. Every storm cell, every monsoon surge, Every river that overflows its banks is recorded in real time, becoming part of a living archive of Earth's climate. These observations are then drawn into the same supercomputers that resurrected the Carnian storms, where modern data is compared with ancient signatures. The result is a haunting resonance. The same physics that governed a drowned Earth still governs today, whispering warnings through every equation. Ice cores add their own voice to the investigation, pulled from the frozen vaults of Greenland and Antarctica. They preserve bubbles of atmosphere from hundreds of thousands of years ago. Though they do not stretch as far back as the Triassic, they act as bridges, allowing scientists to test their models against known climate swings, from ice ages to warm periods. When these models, calibrated in the recent past, are extended further back into the realm of the Carnian, they do not falter. Instead, they reproduce the drowned world with chilling fidelity, confirming that the rains are not myth but physics, inevitable when carbon dioxide and heat cross certain thresholds. Artificial intelligence, too, has entered the dialogue. Machine learning systems comb through terabytes of geological data, identifying patterns invisible to the human eye. They find correlations between volcanic pulses and isotopic shifts, between sediment chemistry and biological turnover, connecting fragments of the record scattered across continents. By weaving together disparate threads, these systems bring clarity to what was once only noise, faint hints that reinforce the picture of an Earth trapped in a climate loop it could not escape. For the first time, scientists can glimpse not only the storm itself, but its rhythm, its pacing, its potential to repeat. Yet amid this growing precision, the unanswered questions remain vast. How much carbon dioxide truly filled the skies during Rangelia's breath? How did ocean currents twist and fracture beneath rains so heavy they altered salinity itself? And why, after 2 million years, did the storms relent? The data offers pieces, but not certainty. In their absence, speculation lingers like a shadow, reminding researchers that science is not only the pursuit of answers, but the endurance of mystery. The philosophical weight of this research cannot be ignored. If the Earth once endured rains without end, then permanence itself becomes fragile. The seasons and cycles upon which civilizations rest are revealed as temporary harmonies in a symphony, far larger and stranger than human timescales can grasp. The Carnian Pluvial episode becomes more than an ancient disaster. It becomes a mirror held up to the present. In it lies a story of resilience, of life adapting and evolving in the face of overwhelming transformation, but also a warning that when the balance breaks, it does not always return quickly. The Earth may take millions of years to mend what is unraveled in moments. And so the work continues, spanning deserts, oceans, mountains, and frozen wastes. Each scientist adds their piece to the mosaic, not only to reconstruct a storm long vanished, but to safeguard against the storms that may yet come. For the rains of the Carnian may have ended, but in the language of rising seas, shifting monsoons, and darkening skies, the planet whispers that its memory is not gone. It is still here, written in clouds, waiting to be heard. The story of endless rain has always lingered at the edges of human imagination. Ancient myths tell of floods that swallowed mountains, of waters rising higher than memory, of worlds remade by storms. In Mesopotamia, in India, in the Americas, stories repeat the same motif, a deluge without end, punishing, cleansing, transforming. Perhaps these tales are echoes, not of a single event, but of something written far deeper, a memory that does not belong to civilization, but to life itself. For there was a time when earth truly drowned, when the sky did not relent, and when survival meant surrendering to a world where water ruled every horizon. In such a time, the very definitions of danger inverted. Dry land, once a place of safety, became the trap. Deserts turned to mud, forests to swamps, mountains to rivers of stone. The water, though violent, became the refuge. It cradled the first amphibians and fish that could endure the storms, granting them new niches and new worlds to explore. Survival was no longer about resisting the flood, but about adapting to it, reshaping life's path to flow with the torrents rather than against them. It was from these drowned forests and swamped plains that new ecosystems rose, and with them, the ancestors of creatures that would one day rule the earth, the dinosaurs. Yet the scale of this transformation humbles even the greatest human imagination. Civilizations rise and fall in the span of thousands of years. The Carnian reigns lasted for millions. To compare human time with planetary time is to hold a candle against the glare of the sun. Our anxieties over climate, though urgent and real, are framed against a backdrop where storms can become eras, and where balance, once broken, may take an age to return. It is not a lesson meant to diminish human struggle, but to place it within its true context. Fragile beings on a restless planet, heirs to cycles, both creative and destructive, and yet there is poetry even in this fragility. The reigns of the Carnian were not only an ending, they were a beginning. They scoured the land but seeded the oceans. They erased familiar landscapes but carved the stage for new dominions of life. Rain became the sculptor of destiny, both destroyer and midwife. It is this paradox that endures water as both grave and cradle, storm as both ruin and renewal. Perhaps that is why rain still stirs something within the human spirit. It carries a memory older than culture, older than species, older even than countenance. In the quiet rhythm of falling drops, there is an echo of eternity. An ancient truth, whispered through storms, that life is not spared from destruction, but reborn through it. The rains of 230 million years ago are gone, but their lesson remains, that every ending is a beginning, and every flood carries within it the seeds of tomorrow across the gulf of time. The Carnian deluge remains less a chapter than a vast watermark upon Earth's history. Its imprint cannot be seen in a single fossil or traced in a single stone, but in the collective whisper of landscapes reshaped, of species vanishing and others rising in their place. The endurance of that storm invites reflection not only on what life endured, but on how memory itself functions on a planetary scale. Human beings recall floods through myths. Earth recalls them through sediments and carbon locked in rocks. Two forms of memory, one poetic, the other geological, converging on the same truth, that water has always been both guardian and adversary of life. When contemplating that span of 2 million years, human fragility is laid bare. A single civilization may last centuries, the most enduring empires perhaps a millennium, yet such scales would vanish within the opening notes of the Carnian storm. Barely a pause between the first clouds and the endless torrents that followed. The lesson is not despair, but humility. It is a recognition that the world humans call stable is in fact built on shifting foundations. That permanence is an illusion measured only by the brevity of human perception. The paradox deepens when considering the role of destruction itself. The endless rains erased ecosystems, yet in their wake came resilience. Microbes multiplied in the swollen oceans, pioneering new chemistries that would ripple upward through the food web. Plants that could endure saturated soils became the architects of new forests, different from those swept away. And in the damp shadows, the first dinosaurs, once small and unremarkable, began to take advantage of the new niches carved open by flood and famine. The same storms that scoured the planet also wrote the prelude to an age of giants. The torrent, therefore, was not solely a tragedy, it was a transformation. To see this, one must hold two truths at once: that life is fragile, and that life is relentless. That Earth can erase entire kingdoms of species, and yet out of that erasure find space for something utterly new. The rain becomes a metaphor not only for endings, but for the cycles that tie endings to beginnings. And if such a balance can exist across millions of years, perhaps the deeper lesson is that even in chaos, creation is never absent. Yet for all the scientific reconstructions, something remains unknowable. What was it like, truly, to live under a sky that never cleared? To see the horizon blurred by a veil of endless falling water, to never glimpse the stars, to never feel the warmth of uninterrupted sunlight. No fossil preserves fear, no sediment layer records the longing of a creature waiting for the storm to break. This absence of human memory is precisely what draws people back to the mystery. It makes the Carnian rain not only a scientific puzzle, but a philosophical mirror, a chance to wonder how small and fleeting humanity is against the immensity of deep time. The silence that followed the deluge was not the silence of stillness, but the silence of a world redefined. Where forests had once towered, there stretched sodden plains. Where deserts had once breathed dust into the air, there now lay green wetlands pulsing with new life. The earth had turned a page, but the ink was written in water. Each raindrop that fell over those millions of years carried both death and renewal, each storm both an ending and a seed. The paradox is inescapable. What destroys also nourishes. What drowns also sows. From the greatest catastrophe can emerge the roots of future abundance. This duality lingers as a haunting reflection for the present. Humanity has always feared. The flood, from Mesopotamian tablets to biblical arcs, from Hindu cosmologies to Norse tales of the seas, return. Every culture has envisioned water as the force that can strip the world bare, leaving only fragments to rebuild. Yet those same stories whisper of rebirth, of renewal after the waters recede. It is as if ancient myths, without knowing the science, still carried echoes of what the planet itself has endured, perhaps buried deep in collective imagination. There lies a memory of how fragile life is when the sky itself turns against the ground. But the reflection extends further, into the present century. For as ice caps melt and oceans rise, as weather grows heavier and storms more violent, the world once again feels the weight of rain. Climate models speak of intensifying monsoons, of the wet gets wetter principle shaping the future. And in those forecasts, one hears a distant resonance, faint, but unmistakable, of Earth's ancient storm. No, humanity does not face 2 million years of rainfall, but the principle is the same. When the balance of atmosphere and ocean tips, the skies respond without hesitation. What fell upon the Triassic is not gone forever. It lingers as a warning, a pattern the planet can repeat if provoked. To grasp this is to accept both fragility and resilience. Civilizations, with their towers, cities, and empires, are young and brittle compared to the scale of Earth's cycles. A storm that endures for centuries would be enough to erase all that has been built, and yet life itself would endure, as it always has. The question is not whether Earth survives, but whether humanity survives with it. The endless rain becomes more than a prehistoric tale. It becomes a mirror, reminding that survival depends not on mastery of the planet, but on learning to bend with its tempests. And so, the chapter closes not with despair, but with humility. For the rain teaches the oldest lesson of all, that destruction and creation are inseparable, that endings are but preludes to beginnings, and that beneath the storm, life waits patiently for its next chance to rise. The rain's unrelenting and timeless, carved more than rivers into stone. They carved lessons into the memory of the earth itself. Each drop etched a reminder that no stability is permanent, no climate eternal. Continents shift, seas advance, skies turn volatile. What seems fixed from the vantage point of a single human life is revealed as fragile when stretched across geological time. And yet, within this impermanence lies continuity, the endless dialogue between chaos and order, between collapse and renewal. To imagine humanity living through such an age is to confront a paradox. For millennia, societies have built themselves around the predictability of seasons, the rise and fall of rivers, the return of rains that nourish crops but do not overwhelm. But during the Earth's drowned epoch, predictability was annihilated. There were no seasons, only the monotony of endless storms. In such a world, agriculture would wither, architecture would rot, memory itself would be defined not by harvests or kings, but by survival amid floods. The human imagination recoils at such permanence of chaos. Yet for life in the Triassic, this was reality. Still, resilience emerged. Microbes flourished in new niches, plants adapted to sodden soils, and from the soaked landscapes rose the first true dinosaurs, creatures destined to dominate for over 160 million years. What began as catastrophe became opportunity, reminding that every extinction shadows a genesis. The storm did not just erase, it also redefined the trajectory of evolution. The very creatures that would one day give rise to birds, life capable of flight, capable of transcending storms, first rose during this crucible of rain. The human reflection deepens here. Civilizations span mere thousands of years, their triumphs delicate against the backdrop of a planet that measures time in millions. In the face of such storms, monuments would dissolve, languages would vanish, borders would mean nothing. What remains is only life's raw persistence, stripped of pride and possession. The rains remind humanity that survival is never a right, but always a negotiation with forces beyond control, and in that realization lies a kind of reverence. The storms of the past are not only scientific puzzles, nor only cautionary tales. They are philosophical mirrors, vast, liquid metaphors. For the brevity of certainty, the inevitability of change, and the capacity of life to endure what seems unendurable. Rain, in its endless fall, is both elegy and promise. It mourns what has been lost, and it waters what is yet to come. The image of an earth under endless rain lingers like a haunting melody, carried forward not only in stone and fossil, but in the deeper strata of human thought. Across cultures, stories of deluge rise like echoes of a collective memory. The Mesopotamian epics of Gilgamesh, the Hebrew flood of Noah, the Hindu tale of Manu, saved by a divine fish, the Chinese legends of Gun and Yu taming the waters. Though separated by oceans and time, these myths converge on the same motif. A world drowned, life forced to begin again. Science may chart isotopes and sediments, but mythology preserves something equally profound: the recognition that water is both the womb and the tomb of existence. Perhaps, buried within these tales, there is an ancient intuition that floods are not just accidents of weather, but fundamental rhythms of the planet's history. Yet even in the face of such immensity, life clings to continuity. Where forests were buried, new species sprouted in their wake. Where entire lineages vanished, others bloomed into possibility. The rains of the Carnian epoch did not destroy life. They redistributed it, redrew its map, reimagined its rules. In that sense, the deluge was not only an apocalypse but a genesis. The dinosaurs that would one day thunder across continents were midwifed by the storm. The mammals, small and fragile in those drowned worlds, found shelter in its aftermath. The rain, merciless in its fall, became the architect of futures it could never foresee. For humanity, there is a sobering lesson in this. Civilizations have risen upon the belief that the earth beneath them is steady, that climate is a gentle partner in their endeavor. But the drowned earth reminds that the ground is never truly stable and the sky never fully tamed. The balance, sustaining agriculture, industry, and cities, is a narrow thread compared to the storms that shaped prehistory. What feels unshakable today is but a pause between upheavals. In the final reflection, the endless rain becomes more than a tale of ancient catastrophe. It becomes a meditation on existence itself, that creation and destruction are not opposites, but twin movements in the same eternal cycle. Every drop of rain contains the paradox. It erodes mountains, yet nourishes seeds. It drowns forests, yet births rivers. It ends lives, yet makes new ones possible. To stand in the shadow of such a truth is to feel both small and infinite, fleeting and eternal. The rains whisper that fragility is not failure, but the condition of being alive on a living planet. And so the story closes where it began: an earth adrift beneath endless clouds, oceans rising to swallow land, lightning splitting a sky that never clears. But from within that storm, life endures, reshaped, renewed, relentless. The flood is not only memory, it is prophecy, reminder, and warning. The waters rise, the rains fall, the earth remakes itself, and life always finds a way to begin again.